All right. A little review of Geology of Natural Disasters by Robert Geis. So, the science of natural disasters, really what I learned in this area was that hazards are really only hazards if it has a potential to harm any living thing or piece of property, which, in today's day and age seems to be inevitable no matter what type of natural disaster you have. Tsunami, floods, earthquakes, wildfires, volcano eruptions, whatever it may be. As far as volcanoes are concerned, the fact that Arizona has, I think it's 3 different volcanoes in the state is pretty incredible. The one I find really cool is Sunset Crater, which is a cinder cone. And cinder cones consist of scoria, which is a vesicular low-density basalt, which basically what you can see is this basically cone sand. It looks like sand essentially piled up, almost like an anthill, but that's because within the basalt, or basalt, however you say it, the gas is trying to escape, so it's going in all different directions, which causes it to just release from the top, which then it's then cooled before it hits the ground, which causes the little pieces to kind of tumble down by the wayside right here. So that's pretty interesting. Earthquakes, like I said, kind of in the text, there's been multiple times within this class that I feel like a complete idiot for not knowing. And one of these is the tectonic plates. It's really interesting how there's about 12 different plates around the globe, and they're constantly grinding, pushing, pulling, snapping, and that's kind of what creates your convergent boundaries, divergent boundaries, subduction zones as well. And especially, you can see over here, like the whole ring of fire, it makes a lot of sense now as to, especially in like Mexico or South America, Japan, over in China, up in Alaska, like this ring of fire right here is because the Pacific plate is being driving essentially north, which is causing this huge subduction zone. So that was pretty interesting. Climate and weather, I thought that the fact that we could basically paleoclimate proxy data sources that we could pull from are the ice cores, tree rings, different pollens. I think the coolest one to me is the ice cores, just because maybe it's because we live in Arizona and ice is so foreign to me, but the mere fact that we can kind of tell what is in our atmosphere, what was in our atmosphere, all the different greenhouse gases and what the environment was like at those times. It's a really invaluable tool. And as far as deadly weather is concerned, I mean, there wasn't necessarily one specific section that we went over. I think everything that we went over could essentially be deadly weather. And I chose this, which is a picture of the Fukushima power plant. That meltdown was caused by an earthquake, which triggered a tsunami, which the tsunami basically flooded the city of Fukushima, which at that point brought down so much of the infrastructure that it potentially would have wreaked havoc on the entire world. And now, even though the nuclear power plant was man-made, all of that was triggered by natural disasters. And so that is an example of a major, like a catastrophic hazard that could happen. Flooding. In Arizona, we deal with a decent amount of flooding, more like flash floods for the most part. I did used to think that the either 100-year flood or 500-year flood or like 25-year flood, that it would only happen once every 100 years. It would just be really bad. I didn't think that it was like a 1 in 100 chances that it would actually flood in this particular area. What we do know is that the more humans interact with different flood zones, the more it exacerbates the effects that the floods have. Perfect example is Katrina. But as you can see here, it looks like we're on the 10, or the 7. Yeah, it looks like the 17, maybe. But yeah, don't want to be in that. As far as the groundwater, I did. This may be arrogant, but I always thought that the groundwater was actually an underground cavern that was open and full of water that was surrounded by a aqueduct that would basically encase it. Like I said here, my in-laws have a well, and I was always curious about how that concept came to be about and how you can actually keep wells protected and not become infected with either, fertilizer, sewage, salt water, whatever it may be. Yay, gravity. The beaches, I was pretty interested in the fact that all the different ways that we are essentially trying to protect the property that the real estate that we've built on the sides of the beaches, and the mechanisms that we use to help protect those, such as breakwaters, jetties, groins, all of those, yeah, they may help, but they have an adverse effect on the beaches themselves. In the case of erosion, or you have sediment deposits that build beaches. You can see here in the picture that these breakwaters actually starts to build the beach out a little bit further, and it's going to make this whole entire area a beach. To be honest, this all this information just is a little kind of depressing at first, and just thinking we're all screwed. But really, the best way to kind of be aware of anything is to educate yourself about it and become knowledgeable. And once you become knowledgeable, you then can learn what is in your power to give back to this world, and how to not just take and have this mentality of we're going to use it and throw it away, because this is the only one that we got. And it looks like Elon Musk, he's making progress to make it to Mars, but I'm not putting all my chips on that. I would want us to take care of the Earth that we're in right now. And definitely studying geology helps us learn about that. So, thank you so much. It's been a pleasure, Mary. Bye.